Hey everybody, this is Mr. Strickland,
And Miss Holtz.
and we're wanted to make a video for you guys today regarding dividing fractions. In IPC, we've noticed some problems with students not knowing how to handle units in their problems. And like a context that has come up, if we have a problem like where the volume of some object depends on the mass divided by the density, and if we look at the units of mass are grams, and the units of density could be something like grams per cubic centimeter, and our students are having a hard time wanting to know what do we do with this? What happens with this unit? Do the grams cancel? Is it gram squared? What happens to the cubic centimeters? Is it on top or the bottom? There's some confusion about that. And so how do we resolve this?
So let's take a look at how we could do this. So the problem we're dealing with here is a number divided by a fraction. So let's talk about how we can divide fractions. So let's say we have some numbers here. We'll do it with numbers first. Let's say we have 1/2 divided by 1/3. So we have a fraction divided by a fraction. And the way you would rewrite that to make it easier is to multiply by the reciprocal of the denominator. So basically what I mean by that is we start out with the top number, we keep that one the same. Some of you may have heard of this as keep, change, flip. So you keep the numerator, you change your operator, so instead of dividing, we're multiplying, and then you flip these two numbers in the bottom fraction. So you take the reciprocal of the denominator, which becomes 3/1.
So the reciprocal is when you flip it upside down, is that right?
Uh-huh.
Okay.
So now, when we solve for this, we multiply the top two numbers, 1 times 3, and divide by the bottom two numbers multiplied together, 2 times 1. So we end up with 3/2.
I see some students, when we get to the stage in the middle, they want to cross multiply and divide things. So guys, remember not to do that. You multiply all the numbers on top together, and then you multiply the numbers that are on bottom together.
Yeah, so let's do an example now where not all of the numbers are fractions. So let's say,
You want to go to the next page?
yeah, let's go to a new page. So let's say we have something like 4/2. So now we have a number divided by a fraction. So the first thing we want to do on this one is turn the numerator into a fraction as well. So dividing a number by 1 keeps it the same number. So we can call that 4/1. And then we divide that by 2/3. So this is the same thing, we just turned this 4 into a fraction, 4/1. So now we'll do the same thing we did the last time. We'll keep this the same, we'll change the operator, and then we'll flip the denominator. We'll take the reciprocal. So we start with the same thing here, 4/1. We turn the divide into a times, and we flip this fraction. So now the 3 is on top and the 2 is on the bottom. So this becomes 4 times 3 on top and 1 times 2 on the bottom. And that gives us 12/2, which we can actually simplify one more step. And 12 divided by 2, we know that that's 6. So 4 divided by 2/3 can be found by turning this 4 into a fraction and then doing the same process that we did earlier.
Well, great. That makes a whole lot of sense. But what about in IPC and in physics when we deal with units? Can we apply this same logic and reasoning when we're resolving units? Like what if we have velocity divided by time? How would we do that?
Okay, so let's think about that. So we have a velocity divided by a time. Okay, so what are the units of velocity?
So meters per second, let's use those.
Yeah, meters per second. And our unit for time would be seconds.
Well, now we've got a fraction on top and it's not a fraction on the bottom. What happens now?
So we'll do the same thing we did before, except we're going to change this into a fraction. So dividing by 1 is the way we'll do that. It's the same thing with units as it is for numbers. So our top unit is already a fraction, meters per second, and we'll divide that by the fraction seconds/1, which is the same thing as seconds.
Oh, cool. Let me guess. Well, we keep what's on top.
Mm-hmm. So meters per second.
And then we change the operator to multiply. And then we have the reciprocal, which that would be what? 1 over s, is that right?
1 over s. So now we do the same thing. We multiply the top two numbers together. And
So
those
meters
go on
times
top.
1 is meter. Cool.
And then the bottom two, well, these aren't numbers. The bottom two units.
But seconds times seconds.
Times seconds.
All right.
So let's write that down here. So meters times 1 over seconds times seconds. So we said that anything times by 1 just is the same thing that you started with. So m times 1 is just m. What about the seconds times seconds on the bottom?
So that'd be seconds squared.
Seconds squared.
So meters per second squared is a velocity divided by time.
And those units make sense because those are a unit for acceleration. And this, v times t, actually equals an acceleration.
All right, well, this is great. So this is how we divide by fractions then and help resolve units in IPC and in physics.
Yeah, I hope that helped.